All right, let's get started on today's Tech Talk. Today, we're going to get into power direct vent and power vent appliances and the terminations that are needed for each one of those appliances. Now, this is critical and crucial information for the types of jobs that we're doing every day. We want to make sure that we're getting everything installed absolutely awesome. Now, in St. Louis, we are utilizing the 2015 International Fuel Gas Code, and you'll notice that that's where I pull a lot of the provisions from on what we got to do. So I hope everybody's able to have a few takeaways and maybe an aha about some of these things that we're doing. That way, when we're out here installing these tankless or the power vent water heaters, we're getting it absolutely perfect. Now, let's go ahead and dive into what we got for the content. All right, I'll give you a couple seconds here. You can pause this and go ahead and read what the definitions directly out of the codebook have to say. Now, definitions are critical because we've got to make sure that we're speaking the same language here. So I just pulled a couple quick ones. Direct vent appliance, sealed combustion, intake and exhaust from outdoors. Mechanical draft, fan driven removal of flue gases under pressure. Natural draft, vent induced flow due to temperature and height. Venting system, a continuous open passageway removing combustion gases. Confused about power vent and power direct vent? Here's the key difference. Power vent uses a fan to push exhaust gases out of your home, typically through a single pipe. It pulls combustion air from inside your home. Power direct vent also uses a fan to exhaust gases, but it's a sealed system. It uses two pipes, one to bring combustion air in from the outside and another to exhaust gases back outside. In simple terms, power vent uses indoor air, while a power direct vent uses outdoor air for combustion. Both use a fan to take the exhaust out of the home. Let's look at some specific sections from the International Fuel Gas Code that govern where we can terminate our venting systems. This is crucial for safety and compliance on every job. First, under section 503.8, venting system termination location. The code gives us several key rules. Rule 1. If you have a mechanical draft system, like a power vent, its terminal needs to be at least 3 feet higher than any forced air inlet if that inlet is within 10 feet horizontally. This prevents the exhaust from being sucked into the building's fresh air supply. There are exceptions for direct vents, appliance intakes, and outdoor appliances. Rule number 2. For most mechanical draft systems, except direct vent ones, the terminal must be at least 4 feet below, 4 feet to the side of, or 1 foot above any door, operable window, or gravity air intake. Also, the bottom of the vent terminal needs to be at least 12 inches above the ground. This is that larger clearance we discussed for systems that use indoor air and positive pressure. Rule 3. For direct vent appliances, that the clearances are much smaller based on the appliance size. For smaller units, 10,000 BTUs or less, it's 6 inches from any air opening. For medium units, 10,000 to 50,000 BTU, it's 9 inches. For larger units, over 50,000 BTUs, it's 12 inches. The bottom of the vent terminal and the air intake must still be at 12 inches above the ground. This reflects the safety of sealed combustion. Rule number 4, through the wall vents, especially for high efficiency appliances. Category 2 and Category 4 cannot terminate over public walkways or anywhere where condensate or vapor could cause a problem or damage equipment. If condensate is an issue with other types of appliances locally, this rule also applies. Remember, we need to install condensate drains according to the manufacturer's instructions. A little RFD. Rule number 5. For Category 4 appliances, venting through a sidewall or blowing straight out perpendicular to the wall, the terminal must be at least 10 feet horizontally from any openable window or door in a neighboring building. This provides distance for the exhaust to dispense. However, this 10-foot rule doesn't apply if the terminal is 2 feet or more above or 25 feet or more below those openings in the adjacent building. Vertical separation can be just as effective. Now, let's briefly look at 2 other important sections. Sections 503.9, condensation drainage. This simply reinforces that we must collect and get rid of condensate from Category 2 and Category 4 appliances, and others if it's a local problem, following the rules we just mentioned in 503.8, Item 4. Section 503.16, outside wall penetrations. When any vent, including direct vents, go through an outside wall, the space around the pipe needs to be permanently sealed with approved materials. This is essential to prevent any combustion products from leaking back into the building at the wall penetration. Understanding these specific code points helps us ensure we're installing venting systems safely and correctly every single time. This chart is from the International Fuel Gas Code and is a quick and easy reference for the code provisions on the previous page. I highly recommend taking a screenshot of this and saving it. It is an extremely handy chart to have. All right, let's get into why power direct vent systems for water heaters can be installed closer to windows and other openings compared to other venting methods. The key is that they are sealed combustion balanced draft appliances. First, combustion air isolation. These systems are completely sealed off from your home's air. They have a dedicated intake pipe that brings in 100% of the air needed for combustion from the outdoors, and a separate exhaust pipe that sends all the flue gases right back outside. This means no combustion byproducts can leak into your home's living space. Second, balanced draft mechanics. In power direct vent systems, the fan ensures a consistent and equal flow of air both into the appliance and out through the exhaust. This maintains a near neutral pressure within the combustion chamber relative to the outside atmosphere. So, there's no significant pressure pushing exhaust gases outward. Third, cool, slow plume. Especially with today's high efficiency condensing models, the outgoing hot exhaust gases are used to preheat the incoming cold air. This results in a much cooler and slower exhaust plume exiting the vent terminal. This cooler, slower plume dissipates very quickly and is less likely to affect nearby windows or doors. And finally, the code reference. The International Fuel Gas Code, specifically section 503.8.3, recognizes these safety features and allows for vent terminals of direct vent appliances with an input over 50,000 BTUs per hour to be as close as just 12 inches from windows and other openable openings. The takeaway here is a power direct vent water heater operates as a sealed combustion balanced draft appliance, resulting in cooler, slower exhaust plumes, allowing for closer clearances to operable openings as permitted by the International Fuel Gas Code for direct vent appliances. This chart from the Renai tankless water heater installation and operation manual provides specific clearance distances in inches for U.S. installations. Referencing the National Fuel Gas Code and direct vent appliances, this chart is a helpful reference for understanding general direct vent termination requirements, and many of its provisions align with the 2015 International Fuel Gas Code that we use in St. Louis. However, it is crucial to remember that if the locally adopted installation codes in the St. Louis County amendments specify clearances different from those illustrated here, then the most stringent clearance shall prevail. Key clearances include A. Clearance above grade, porch, deck, or balcony, 12 inches. Clearances to a window or door that may be opened, 12 inches. Clearances to permanently closed window, no specific distance listed. Vertical clearance to ventilated soffit located above the terminal within horizontal distance of 2 feet from the center line of the terminal, no specific distance listed. Clearance to unventilated soffit, no specific distance listed. Clearance to outside corner, no specific distance listed. Clearance to inside corners, 12 inches. Clearance to each side of center line extended above meter regulator assembly, no specific distance listed. Use best judgment on any air inlet in this scenario. 3 feet is ideal. Clearances to service regulator vent outlet, no specific distance listed. Use best judgment on any air inlet in this scenario. 3 feet is ideal. Clearance to non-mechanical air supply inlet to building or the combustion air inlet to any other appliance. You're going to need 12 inches on that one. Clearance to a mechanical air supply inlet, 3 feet above if within 10 feet horizontally. Always verify the specific clearance with the St. Louis County amendments. Clearance above paved sidewalk or paved driveway located on public property. Vents for Category 2 and Category 4 appliances cannot be located above public walkways or other areas where condensate or vapor can cause a nuisance or hazard. Clearances under a porch, deck, or balcony. No specific distance is listed. Notes: a note regarding clearance to opposite wall being 24 inches. And then note 1: a vent shall not terminate directly above a sidewalk or paved driveway located between two single family dwellings and serves both. And then note 2: clearances under a porch, deck, or balcony are permitted only if the area is fully open on a minimum of two sides beneath the floor. Always consult the St. Louis amendments to the 2015 International Fuel Gas Code to ensure full compliance with local regulations. Let's now get into why mechanical draft or power vent appliances for water heating require a larger clearance of at least 4 feet horizontally or specific vertical distances from doors, windows, or air inlets, as mandated by the International Fuel Gas Code. The primary reasons for this increased clearance are due to how power vent systems operate. Room air combustion. Power vent appliances typically draw the air needed for combustion from the room where they are installed. This means there's a direct pathway between the living space and the combustion chamber. 2. Positive pressure venting. A key characteristic of power vent systems is the use of a blower to force the hot exhaust gases through the vent pipe, which is often single wall PVC or CPVC. This creates a positive pressure within the venting system. Risk of indoor spillage because the vent is under positive pressure. Any small leak at a joint, gasket, or the blower seal can become a pathway for hot carbon monoxide laden gases to be forced out of the vent pipe and into the room. Hot, fast plume. The blower in a power vent system often results in the exhaust gases exiting the vent terminal at a higher temperature and velocity. This increases the potential for those gases to be drawn back into the building through the nearby windows or fresh air inlets, a phenomenon known as re-emittent. Takeaway: to minimize the risk of these potentially dangerous combustion byproducts re entering the building through a nearby window or fresh air inlet, the code requires a much larger clearance, at least 4 feet horizontally, for power vent terminals. This distance allows the exhaust plume exiting the vent to dissipate and dilute significantly in the open air, reducing the likelihood of it being drawn back into the building's ventilation system or through open windows and doors. All right, everyone, let's dive into Table 18 from the Renai Manual. This table is vital because it outlines the required termination clearances specifically for power vent or mechanical draft water heaters. This table is based on the National Fuel Gas Code and it aligns well with the requirements in our current code, the International Fuel Gas Code. However, as always, the most important thing is to always reference back to your local requirements, like the St. Louis County amendments. Remember, the fundamental difference here is that power vent systems draw combustion air from inside the room and use a fan to push the exhaust out under positive pressure. This is different from power direct vent, which is a sealed system using outside air. Because power vent operates under positive pressure and uses indoor air, the required clearances are significantly larger to ensure safety. Let's look at some of the key clearances from this table. First, clearance above grade, reference A. You need a minimum of 12 inches from the ground, decks, or balconies. This is a standard clearance to prevent the terminal from being blocked by snow or other obstructions at ground level. Next, and this is a critical one, clearance to a window or door that can be opened. Reference B. For power vent, the code requires a substantial distance here, at least 4 feet below or to the side of any openable window, or a minimum of 1 foot above it. This larger clearance is absolutely crucial because of that positive pressure in the vent. If there's any leak in the system, or even just during normal operation, that positive pressure means exhaust gases are being pushed out. We need that 4 feet distance outdoors to allow these exhaust gases to dilute safely in the air before they could potentially be drawn back into the building through an open window or door. Looking at clearance to an inside corner, reference G, you need at least 12 inches here. This helps ensure proper airflow around the terminal and prevents exhaust from getting trapped and potentially re entering the building. Also, pay close attention to clearance to a non mechanical air supply inlet or the combustion air inlet of another appliance, reference J. Just like windows and doors, you need that 4 foot clearance below or to the side or 1 foot above. We absolutely do not want our water heater exhaust getting pulled into another appliance's combustion air intake or into the building's passive ventilation system. Finally, clearance to a mechanical air supply inlet, reference K. If your power vent terminal is within 10 feet horizontally of a mechanical air intake, it must be located at least 3 feet above that inlet. This is a critical safety measure to prevent exhaust from being drawn directly into the building's HVAC or ventilation system. So while this table from the Renai manual is a fantastic guide and meets the general requirements of the International Fuel Gas Code, always remember that crucial note at the bottom. If your local codes, specifically the St. Louis County, specify different clearances, the most stringent requirement always prevails. Understanding and strictly following these clearances is not just about passing inspection. It is absolutely essential for a safe and code compliant power vent installation, protecting the occupants of the building from potential hazards. All right, we've covered the essential differences between direct vent and power vent systems, focusing on why their termination requirements are so different and why following those requirements is absolutely critical. We learned that power vent systems, because they use room air for combustion and operate under positive pressure, require those larger clearances, at least 4 feet from windows and doors. This is a vital safety measure to ensure that if there's ever a leak, or even during normal operation, the exhaust plume has enough space to dilute safely outdoors and not be drawn back into the building. In contrast, Power direct vent systems utilize a sealed combustion process, drawing all their air from outside and venting directly outdoors. This design, along with the balanced draft and cooler exhaust plume, significantly reduces the risk of indoor spillage and allows for those much closer clearances, sometimes as little as 12 inches from openings. As professional plumbers, especially working here in St. Louis, it is paramount that we always consult and strictly adhere to the most stringent requirements, whether they come from the appliance manufacturer's installation manual, the International Fuel Gas Code, or the St. Louis County amendments to the code. Understanding why these clearances exist based on the operational differences of these venting systems empowers us to make informed decisions on every job, ensuring the safety and well being of our customers. Thank you for your time and the attention. Let's remember that the code is the bare minimum standard, the starting point. And when we can improve on it, we always take the more stringent path to deliver over the top amazing results for all of our clients. Thank you for joining me.